This is Euclid Book 10, proposition number 30. And it says, to find two rational straight lines commensurable in square only, and such that the square on the greater is greater than the square on the less by the square on a straight line incommensurable in length with the greater. Here's the diagram. Looks a lot like the last one, doesn't it? Okay. Let there be set out a rational straight line AB. Well, AB we're going to say is rational. And two square numbers, CE and ED. Okay, so this is a square number, this is a square number. So if we add them together, the sum will not be a square number. And this is by lemma number 2, which we covered a couple of videos ago. Let there be described on AB the semicircle AFB. So now we've drawn AFB. Let it be contrived that as DC is to CE, okay, so as CD is to CE, so is the square on BA to the square on AF. So as this is to this, so is the square on this to the square on that. And you know how to draw squares, so if you want to draw them, you go right ahead. And this is by Euclid Book 10, proposition number 6, porism. Let FB be joined. We did. Then, in a similar manner to the preceding, we can prove that AB and AF are rational straight lines commensurable in square only. So, these two are rational straight lines, but the only time they're commensurable is if you form their squares. Then there's a square area that will measure both their square areas. Okay. And since as CD is to CE, so is the square of AB to the square on AF, therefore convertendo as CD is to DE, okay, so as CD is to DE, so is the square on AB to the square on BF. So as this is to this, so as this square is to that square. Okay? And this is by Euclid Book 5, proposition number 19. It's also by Euclid Book 5, porism. It's also by Euclid Book 3, proposition number 31, and also by Euclid Book 1, proposition number 47. But CD has not to DE the ratio which a square number has to a square number. Therefore, neither has the square on AB to the square on BF the ratio which a square number has to a square number. Therefore, AB is incommensurable with BF. So now we're going to say that AB is incommensurable with BF. Okay? And that is because of Euclid Book 10, proposition number 9. And the square on AB is greater than the square on AF by the square on FB incommensurable with AB. All right. So this square is greater than this square by this square, which this line happens to be incommensurable with this. That's what they're saying. Well, that's what Euclid was saying. Wow. Therefore, AB, AF are rational straight lines commensurable in square only, and the square on AB is greater than the square on AF by the square on FB incommensurable with the length of AB. Yeah. Okay. And that's the whole proof. I will tell you more in a future video, so I hope you will stay tuned.